next question I'm going to ask you.
It's diatomic.
Ah, he has read my mind. Monatomic or diatomic if I just have a hunk of aluminum? Monatomic, and yes, it is in solid state. But you know, for balancing these things, you don't have to put on, is it a solid, a liquid, or gas? That's just some extra fluff. So to balance it, you don't need to bother with that. I'm going to take that, and I'm going to put it down in some hydrochloric acid. And I'm going to write AQ behind it. That means aqueous solution. We've dissolved it up in water. So, I've got the acid in water. And what happens here, this is a preview of coming events. This is called a single displacement reaction. It's coming in a chapter down the line. What happens is this aluminum is going to come in and kick out the hydrogen, take the chlorine as its partner, okay, and the hydrogen, and I'm not through writing yet, the hydrogen gets kicked out. What do we know about hydrogen if it's out there hanging around by itself?
It's diatomic.
Diatomic, and that's going to be gas, and gas is going to bubble off of these. Now, here's another hint of something that's coming in a later chapter. If I forced you to write formulas here, and I will not in chapter 3, but just a hint of future things. Aluminum, look up there where aluminum is. If it takes on a charge, Charles, what's his most likely charge?
I can't find one.
Okay, somebody tell him its number.
13.
13. What's his most likely charge, Charles?
Plus 3.
Plus 3, good. Okay, and then I have some chlorine here. Allison, what's his most likely charge?
-1.
-1. Okay, when you have a compound, it's got to be electrically neutral. Anybody want to take a wild guess, then what's the correct formula for this if I want it electrically neutral? Al3?
No, it's AlCl3.
AlCl3. Excellent, because here's the down and dirty way. This almost always works. Double cross it down and disregard signs. So that's understood to be a 1. The 3 comes down here. But look at what that trick did for us. Plus 3 times 1 is plus 3. Minus 1 times 3 is minus 3. So we've got a neutral compound. Now that's coming. But I would give you that today. Okay, now when we look at that, and this is also soluble. So since we have water here with the hydrochloric acid, this will also dissolve up in that water and we get that hydrogen out. And again, preview of coming attractions. That's called single displacement. What's happened? You have a dancing couple. Hydrogen is dancing with the beautiful chlorine. Aluminum is a single guy. He really likes to dance. Okay, so he comes over. This used to happen in the old dances. I don't know if it happens anymore or not. The single guy comes over and he taps the hydrogen on the shoulder and he says, "May I dance with the lovely chlorine?" And this guy, being a gentleman, says, "Oh, but of course." I gotta be careful here which fingers I have that with. Anyway, you got a new dancing couple going off. Don't get that on the film. Okay. Okay, so single displacement here. See how that aluminum's come in? So get out of my way. Takes over, dances with the beautiful chlorine. And it takes a different number of them because of the different charges. Now, let's get down to business for chapter 3. We got to get this thing to balance. What can I never, ever touch when I'm trying to balance this thing? The subscript. Subscripts. Also, I've had some very creative students decide they'll just put a big digit here in the middle. No, no, no. That's a unit. Hangs together. Where chlorine goes, aluminum goes too. And so, you can only put it out front. Okay, now I have a big dilemma here that we did not have in our first one. I look at it and I go, aluminum's no problem right now. But, here's my dilemma. My chlorine is coming from here. My hydrogen is also coming from here. But I need 3 of those at least, and I need 2 of those. Okay, so 6 is the smallest number that they both will divide into. And so, we come over here. What would you recommend here? You want a 6? Okay, I'll put put a 6 there. I heard a 2 and I heard a 6, so let's try 6. You know, when you're doing this, it's trial and error, and if we do it wrong, that's what erasers are made for. Okay, so let's try 6 there. And then I come over to here. Eddie, what do I need in front of here then, if that's how many chlorines I've got there?
2.
A 2, excellent, excellent. Okay, because that gives you your 6. Antonio, fix up my hydrogens for me.
3.
3, and that gives me 3 there. Did I hear the aha phenomenon out there? Okay, now, the only place we haven't been is with the aluminum. Remember when we started, aluminum was fine, but we jacked around with it, it's no longer fine? Well, hey, we can do what we want here. We're going to come back here, so Clint, what do I want?
2.
A 2. Good. Trial and error. OWL has some wonderful drill on this. You know, you put this in, you put that in, and they will say little notes to you, and I think they may fix up a little table where you keep a tally. I just keep the tally in my head as I'm doing it. And I would say, give me the sum of the coefficients from the balanced equation, and you all are going to shout. 13. Okay, there's 8. 2 more is 10. 13. Excellent. Excellent. Are we all right on that one? Anybody with a question? All right, no. So let's go on. One more, and then we'll move into the next part. Let's say I take some of this. It's phosphoric acid. Does anybody have a cola drink in here? Anybody have a cola drink? Let's see if there's one in the trash. Aha! And I did not set this up. Phosphoric acid. Look at the contents. Do you see it there? Okay, one of the ingredients in any of our cola beverages is phosphoric acid, this stuff right here. Now, why they put this in, I'm not quite sure, but all of our cola drinks have it. I have a theory, though. Years ago, I worked in a lab with a man from India, and he was telling me that in India, they actually drink a little shot of phosphoric acid occasionally, probably highly diluted, as a little pick-me-up. You know, instead of caffeine, it's a little pick-me-up. So perhaps, you know, with Coca-Cola, if it's not a diet drink, you've got sugar, that's a little pick-me-up. For energy, you got some caffeine, that's a little pick-me-up. Well, maybe that little phosphoric acid is too. But anyway, phosphoric acid. If we were in the laboratory, we would have our safety glasses on and our covered toes on, and there you are chugging the stuff in real life. Now, let's say we react that with calcium hydroxide. And we can get that into aqueous solution. And that's the stuff that I mentioned before is the active ingredient in Nair, because that's what will dissolve skin and hair. So I've got this, I'm going to react with that. So I have 2 reactants. And when we react this, we get this. Okay, now again, a little preview of coming attractions. This is phosphate. You've probably heard about it in the news, about phosphates in some detergents. It's bad for our water supply. And this is the hydroxide. Okay, positive part, negative part, positive part, negative part. What happens here, if I go back to my analogy, and this is, again, coming in a later chapter, now we have 2 dancing partners. They come together on the dance floor and they say, hey, why don't we switch partners? So they just switch partners. That what you have is the hydrogen goes off with the OH part and makes water, and the phosphate goes off with the calcium part and makes calcium phosphate. And that's called a double displacement reaction. See, 2 have come together and switched. Okay, now, but our task is not to think about Coca-Cola or Nair. Our task here is to balance this thing. Okay, would oxygen be a good place to start? Okay, why not? Why is that such a lousy place to start? Why is it such a bad place to start? Emily?
It's a part of everything.
It's everywhere. we'd go nuts trying to work with it, because you'd fix one and then another one would pop up wrong. So, if we look it over, well, let me ask this, would hydrogen be a good place to start? Why not, Brittany?
Because it's in two places.
Yeah, it's in two places over there. Again, we would go nuts. So, calcium would be a good place. That would be one place. Excuse me. And phosphorus would be another place we could start. So let me make an executive decision, pardon me, that let's go with calcium. So let's see what we can do with it. So we look at calcium's over here, we look at calcium's over here. Meredith, tell me what I want to put in front of this.
A 3.
A 3. And Meredith, if you put a 3 there, what do you have to put here?
A 1.
A 1. Okay, she just took care of the calciums. Okay, now when she did that, she also fixed the phosphorus, for sure. So we look at how many phosphorus we have here, and then I'm going to come over to here. Timothy, what do I want in front of this?
2.
Okay, look at just your phosphorus. We've got 2 there, okay, and we come over, yeah, you're absolutely right. We got a 2 there. Everybody still keeping up all right? Ask a question if you don't see it. All right, then, to finish it off, I could go with oxygen, or I could go with hydrogen, either one. So again, I'm going to make an executive decision for us, and I'm going to say, let's look at the hydrogens. Now, think about this. Don't say anything out loud yet. You got to consider hydrogens here. You got to consider hydrogens there. Now, tell me, what's the grand total of hydrogens on the left? How many? 12. I hear 3. I hear 12. Okay, let's check it out. Hydrogens. Right here. How many hydrogens here, Alex? 6. Okay, your friends are saying 6. Do you agree? Yeah, why not? Okay, so there's 6 there. Okay, here's the tougher one. Look at this and look at that. How many hydrogens? Kashat, how many hydrogens coming from here? 6. For a total of 12. I see some wrinkled brows. You're going to have wrinkles before you're 40 if you keep looking at chemistry that way. Can anybody ask a question? Steve, are you okay? Do you see it? Everybody see it? Okay. There's no shame in not seeing it, because this comes easy for some people and it comes hard for other people, and who knows how their brain is different. It's got nothing to do with IQ. It's like some people have perfect pitch and some do not. Okay, so we know how many hydrogens we have over here. We said the grand total was 12. So, Jeanette, what do I want to put in front of here for the hydrogens?
6.
6. Excellent. Because then we have our 6 hydrogens. Or 6 times 2 are 12 hydrogens. Now, we didn't even look at the oxygens. Let's say this is a test question, and time is up, and I am trying to rip the test out of your hands because you cannot have any additional time. But you want to check this. Here's the down and dirty, really quick way to check it. If there is an element there that we haven't even thought about, if you check it, like oxygen in this case, if the oxygen's okay, I'd bet my money everything else fell into line. So let's just check an oxygens. Okay, tell me, how many oxygens in this first substance? 8. How many oxygens in this second substance? 6. So our grand total over here is 14. Okay, then I come over here, and this is where I hold my breath. Because if it's not 14, we get to start over. So, how many oxygens here? 8. Okay, and how many oxygens here? 6. Okay, there we are. And that one works just fine. But if you have the luxury of time, you would want to go back. Let's just take it from the top. You got plenty of time, you're compulsive, you just want to check all your work. Okay, there's 6 hydrogens, here's 6 more, that's 12 hydrogens. Here's our 12 hydrogens, check. Okay, 2 phosphorus, check. Okay, we already did the oxygens, we know they're cool. Okay, 3 calciums, fine. Now, for those of you that have had chemistry before, what you can do is you can treat this PO4, that's a phosphate unit, and notice that phosphate unit did not come apart. You can treat it as a unit, but when I asked somebody, I just said the phosphorus. There's 2, so we wanted a 2, but I could have said, how many phosphate units? 2. How many phosphate units do we need? You could say 2. But if you're not comfortable with that yet, go element by element. Okay, and that is section 1, which is balancing the equations. Now, we are ready to get started with 2. And there's several different ways to learn how to do these weight problems. If you have a way that works for you all the time, use your own way. I'm showing the Cartwright way here in class, which is what I think is the easiest, safest way to go overall. But again, if you have a way of doing it, stick with your own way.